Good morning all. Previous class we discussed about map. Now we will discuss about hash code. Before that, so we completed array list and map. Now we are see how the hash set will works. So here we have the hash set, hash tree, linked hash set. These are all the just a minute. These are all the data types available. Data structures. Okay. Now we will see the first what is meant by hash set. In the hash set, see now, first we will see the hash code. In the hash code method, Java returns an integer value which is a hash code represent of the object based on the hash based collections like hash map, hash set, hash table. These are all the classes. Okay, now the thing is suppose let me take one class. Let me take one class. Suppose sample today. Let me finish. So how to get hash code means just simple thing. We have to create object for the class. This is my class. Alright, this is my class. I created object for the class. Now, if you create the object in the memory, Java will create the memory for the this one object in the heap memory. We know this thing. Let me take it's a something today. It is my object. Now I want to get the hash code of this object. How to get means system.out.println in that object dot hash code. See here one method available from the super class hash code method. Return type is integer. It will return the hash code and from the object. Now save this code. Now let me see what will come. See now this is one hash code actually of this is the hash code of this object, right? Now we can create multiple objects for a class. Let me create today one and let me create today two object. So I created instance for the class. Okay, but different objects in the JVM will give the memory for the this all objects. Now I want to show the I want to see the hash codes. For that purpose what I have to do, just now today in the place of object let me replace this today one and this one in the place this one. Now for explicitly for your understanding let me write here hash code for object 1. And let me copy this one. Got my symbol. This one. And again I will This is hash code number 1. Okay, simple 1 and 2. Save this one. Save this one. Let me run this code. Now hash codes will come different unique values, right? This is the unique value for the object 156255737. This is hash code for today object, and today one object, this is the hash code, and today two object for this is the hash code. So in the internally JVM will create the hash code. This is one point. Based on the point only we can go forward this set. So syntax, public integer is a return type hash code, right? It is coming from object. Object is the super class for all classes. So I want to show that where is hash code. Hash code is, if you open the declaration, let me remove this one. Okay, let me remove this hash code. Let me open the declaration where it is declared. See now, hash code is one method available in the java.lang package in the object class. It is the super class for all classes. java.lang.object. See now, we are bringing the nothing but we are invoking the this hash code from the java.lang.object class. See now. Hash code. See now, hash code return type is integer coming from the object class. Same here also, java.lang package. This is the object, and this is that method. Hash code is coming from object superclass. From that only we are acquiring we are getting this code method. Then it will give the different unique values of hash codes for the objects. Clear? Now this is one point. Based on this point only, we have to explain the set. So hash code is that only simple one. This is also same points. Now set. Today topic is set interface. Set is one interface. In the interface, it is the set interface present in the java.util package, and their child interface is that child interface of collection. Okay, see now, collection is one interface, we know. That child interface is set. What interface contains? Only abstract methods. Their abstract methods coming from collection only. In the whatever the behaviors available in the collection, all will get by the child class, nothing but set. So whatever the methods, nothing but add, right? Add method, size method, all methods, whatever the methods available in the collection, we are directly access by using set interface. Set also interface. With the set interface, we can't implement any code and we can't create object for the set. For that purpose, we have to implement that purpose. We have to create a class. So 3 classes are implementing set interface. Clear? One is HashSet, one is LinkedHashSet, one is TreeSet. These 3 classes has implementing the set interface. Clear? Now what it is implementing? It is implementing the collection behaviors. Why? Because of in the set there is no no specific members. No specific behaviors. So we are implementing collection behaviors only. Okay, in the HashSet, LinkedHashSet and TreeSet. These are all the 3 classes implementing the collection interface directly. Why? Because of in the set there is no specific behavior set available. That is the purpose. And it is a, this is the one point clear, right? So child interface of the collection. So set is one interface. It is child interface of collection. After that, whatever the behavior there in the collection interface, it will come to the set interface through the inheritance concept. We know the inheritance concept. By using the child class reference variable only, we can access the parent class. Parent methods. After that, it is a part of Java collection framework and implemented by the three classes. What is implemented? This is set interface implemented by the three classes: HashSet, linked HashSet, and TreeSet. That is one point here. And important points here, I will explain it when I explain this one at the period of time while writing code. If you want to present a group of individual objects in a single unity, then that purpose, then we have to come with the set interface. And in that set interface, duplicates are not allowed. And it not follow the insertion order. And insertion order is preserved. What does this mean? Duplicates are not allowed in the set interface. Nothing but HashSet. If you write the HashSet, in the HashSet class, duplicates are not allowed. If you want to add, suppose if you add search. Otherwise, if you add some any object like apple. If you add apple once, if you want to try to add one more time the duplicate value, that duplicate element not allowed in the set. And the insertion order is not preserved. Nothing but insertion order, nothing but if you add elements, integer, suppose let me take integer 10. Again add 9. This is smaller. 9 is smaller. 10. Now if you print, it will print not insertion order. Insertion order is nothing but whatever you are giving first, it will come. Ten, comma 9. This is nothing but insertion order. Whatever you are giving first, it will print. Whatever the input we are giving first, it will print like that. But it is not following the insertion order. It might be print 9 after 10. This is one point. It is not following the insertion order. Then the question will come. The question will rise: what principle it will follow? What principle it will follow? Answer is hash code. It will based on the hash code of that object. Why? Because of these are all objects only, right? We are wrapping the Java consider as integer primitive data type, consider as a object, and it will generate what hash code. Based on the hash code only, it will print on the console. Clear? Now we will see. Okay, not this one. Okay. So see now, earlier I explained about hash codes. I created object, nothing but this one, for the class, and I printed the hash code of one object. Then it came the one unique value. After that, second object, it came one unique value. Third object, it came one unique value. See now, these are all are different only. That's why we are call it as a unique. Unique means simply, in simple terms, different words. Different. That is one point. Set. So set is one interface. We know it is the child class of child interface of collection. So whatever methods available in the collection, directly we are implementing by using three classes. One is HashSet, right? One is linked HashSet. One is TreeSet. Now we will go to the code. This one. code part. Let me create one class for the set sample. This is my class name. Checkbox public static void main. Now I will write. I have to create first object for the set. Nothing but which class is implementing set. Let me take first HashSet. HashSet class is implementing the interface. In the interface, we are directly we are implementing the collections methods. So now let me take HashSet code. HashSet. I'm creating HashSet class created. Now here error because of we have to import this class. Import java dot util dot hash code. Otherwise, here one more option is there, import the hash code. Java.util code hash code set. Now let me import all classes by using the star. Just save this one. We have to take the generics to pass the data. Let me type string. String is my generics. Save this one. Now what is my object here name? Let me remove this one. Let me add set. Set is this one reference variable, otherwise object. So okay, done. See, I'm explaining. In the package com.bt stream collections, I created one class. After that, I took one main method in the class and I created an instance for the HashSet predefined class. Now, what is my object here? Set. Set dot I want to add one element. Which type of element? That is also string only. Okay, that's why string, and it returns the hash. It is coming from the hash set. Now I want to add one element. Suppose what can I add? Let me add search. Same. Something element. Again, I will add one more something element bng. Now before that, let me check the object, how the it is printed. Let me put in this comment. Save this one. Let me run this code. Open source. Run as Java application. Empty set will print. Empty array. Why? Because of here I created one insertion. After that I printed the set. Then after I added elements. Then after I added elements, then if I print in the set, all elements will store. See now, it is the process. If I take integers, okay, let me write here, make it, save this one. Let me run this code. See now, I want to make a point here. First, what I added here? BNG. After that, I added search. After that, I added software. But it's printed first software. Software is the not first one. This is the second one, and this is the third one. In the set, it will not follow the insertion order. Clear? Let me go to the points. Duplicates not allowed, null points. Okay. Yeah. It does not maintain the insertion order. Right? See now, insertion nothing but first should become BNG. After that search. After that software. But by which based on it is printing on the console means nothing but hash code. Based on the hash code only, it will print on the console, not by the insertion order. And one more point, duplicates are not allowed. Duplicates nothing but just suppose copy this one. If I again added duplicate, software already present. Again I added software element. Now let me run this code. See now, software added one time only once, but I added two times. Let me remove this software. Let me add element like something BML, like run this code. See now, BML added. Why? Because of it is only added once only. It's not a duplicate value. But previously if you add software, it is a duplicate. It is a duplicate value. Then only it's not allowed the duplicates. Right? And one more point, null is allowed. We can add null also. Instead of null nothing but just remove this one, remove the quotations, add null, save this code and just run this code. Null accepted, duplicates are not accepted, and it won't follow the insertion order, and internally uses the hash map. Hash code it will uses. It is not synchronized, not thread safe. This is the some important points regarding this hash set. And what is recommended in the polymorphism? In the polymorphism concept, see now, if I take to hash code, if I hit the declaration, we can see the implementation. Hash code implementation, all I can see. Why? Because of this is a class. It is not recommended. So what we have to do? We have to make it as a interface. Which hash set is implementing the set interface, right? That's why we have to remove the hash set and put the interface. Then if you go to the set, if I see that it will redirect to set interface. Then we can not able to see the implementation methods. This is recommended in the industry. Polymorphism. Set sample. Right? Interface, generics, variable equal to new keyword and class name. And we added some methods, and we have lot of methods like object dot size. I want to let me know what is the size of the how many elements added. I want to see for that purpose size. Okay. Size, we have to close the line with the semicolon, then run this code. Size, okay, we have to print system.println and just copy, paste over here. Let me put in the comments. Let me remove the semicolon. Let me run this code. Okay, size is 4. Okay, all right. So like that only we have lot of methods coming from the collection interface. Sys out otherwise set only, set dot. See how many methods available. These are all the methods coming from the, some of coming from the set interface, some of coming from the object interface. But in the set there is behaviors coming from the superclass of collection only. See, collection. And some of the object. From the object, set, collection, these are all the methods we can use in our application, and we can build the application. And one more thing is there, just for loop. Okay, before that, let me explain one important point. Okay, this is already done. See now, I want, so already done, right? So if it is the hash code is the set is display the elements based on the hash code. So already we saw that in the hash code all are unique numbers. If you give the equal to operator, object 1, this is one actually object 1 equal to object 2, then it will give the false. Why? Because of both are not same numbers. This is one hash code, this is one this thing. Okay, let me, if you want, let me write this code. Just a simple point only, this one. Let me put all this in the comment. Simple here. I created object for the just okay, here we have to give our class name, set sample, copy this one. These comments, save this one. See now, it is one point, set sample. I created two objects, one with object and one is object 2. Now object has hash code. If I give the object hash code, it will give the some unique value. Okay, it will give one unique value of this object. Again, if you print again, if you print object 2, then it will give some unique value. Now if you want to compare this both, like suppose, let me put comment this one, let me run this code. See now, here I created two objects for the class and I printed. If I print this one, if I run this code, it will give the two different values. Now if I want to compare both are equal or not, for that purpose, reference variable, I mean object equal to object 2, then it will check the addresses. It will check the address of memory, what is the stored. Then it will give some boolean value, false. Clear? That only here one important point. It will compares the value. It will compares the memory address references in the JVM. In the JVM heap memory, JVM will create one memory address for objects. Then if you want to check these two objects addresses, it will give the return value is false. Clear? Why? Because of this is different this is different. That is the simple meaning of this because equal to operator. Because of equal to operator, we can check the address, memory address allocated in the, it will compare the memory address references in the JVM. Clear? This is one point, and important point, this one, hash code. So in the array list, what we learn in the array list? In the array list, just me open the paint otherwise. In the array list, what is the default capacity of array list? 16, right? In the array list, default in the array list, default capacity 16, right? I want to add 17 element, then what we have to do? We have to apply some formula, right? What is that? Default value into 3 divided by 2 and plus 1. Then what is the default value here? 16, right? 16 plus 3 divided by 2. It became 15 plus 1. Then what is the updated? 16 is the updated one. Then again 16 will add in the here address. One more 16 cells will add, then we can add the here, then we can add here 17th element, 18th element, like and so on. Whenever it reaches again 25, it will again increase the cell. Now if you come to the set, it is in the constructor created MG object with the set 16 elements. Here also in the set also default is 16 elements, but it will take the what I would say, it is filling the ratio. It will filling the 0.75 ratio. Suppose in this, in the set default value is 16. Is the default value of set. So how the memory allocates here means ratio of 0.75. 0.75, right? 0.75. What is meant by 0.75 means? So what is the percent of 16 0.75? Like 16 percentage of 0.75, it will come 0.12, nothing but 12, right? 12. Whenever you added 12 elements, it's filled with 75%. 75% of capacity filled with elements, then it will apply the formula and it will grow the cell again 16. Whenever again filled with 0.75 ratio, again it will fill. If again filled with 75% of this new one, again it will fill 12%. Like that only it will apply the formula 0.75 percentage of default value. So 16 percentage of 16 percentage of 0.75, it will give the 0.12. Then default value is 12. Whenever the 12 elements completed in the out of 16, it will add again this one memory cell. Then we can add 17 after. Like that only it is growable nature. This is one important point in the set. See now in the constructor it will create the empty hash set object 16 elements. 16 of the 17 is 12, nothing but 12. After filling of 12 element, internally JVM will create the new hash set object, those elements, copy that new hash set into the set, in the set object. These only will copy and it will take the elements after coming. Okay, so these are all the some important points already discussed. Already have been discussed this one. So these are all the methods: add method, remove method, content, size, is empty, clear. So what we used here, we used here add element and size element, right? Okay, this is size element, add element, right? And we used the equal to equal symbol also. This is different thing. So these are all the methods involved in the collection, not in the set. Why? Because of collection is the child interface. Set is the child interface of collection. Whatever the methods available, we are implementing from the HashSet class. That only I explained here, HashSet class. Clear? Now we will see the simple one more program, then we will go to the queue. Just a second. Let me remove this all code. Okay, we'll see one real time thing where we are using this set. For that purpose, let me write system.out.println. User. Let me take this one. Let me update usernames. Let me give this here. Usernames dot. Here let me give. Okay. Again, system.out.println. Again, register. Copy this one. Let me update this value to some some updated value. Again, let me add one duplicate. That is the main thing, right? It won't allow the duplicates. Let me remove this one. Let me add again search. Let me save this one in this method. See now, this code. See now, this is one method, private method. It will access only class only. This is access modifier. Static is the return type. Static is the key value. After that, char is the character. Character of array is the return type. We are returning the up to now null only. Let me remove here. Okay, this is one character, and register is the method. In the register method, I am using the parameters set string username and set string. These two are my parameters. Let me add here usernames parameter data dot. I will use here add method. Here I will give this parameter values. Okay. It will return the true or false only. Just save this code. Let me run this code. See now, it gave the true or boolean values true or false. Why? Because of what is the main purpose of here means I want to demonstrate in the real time. If you registered search, if you again try to register with the search, it will give the false. That is the meaning. If I registered with search, it will return true. If you registered with the username true, with another name, it will return the true. Again, you added duplicate value. Duplicate nothing but already added here once, here added second time. Then it will give the false. Why? Because of search is already registered. If you add one more, otherwise let me add Mahesh, then save this one. What will come? True. Why? Because of it is not registered. It's not a duplicate value. That's why it is written the true in the real time also. Like if you registered with one name, again you are trying to register with one more name, we have to come for set. That's why it is not allowed the duplicates. Clear? And that too also it is not following the insertion order. Insertion order nothing but whatever you are writing. Otherwise, let me write here. Let me check. What is my username stored in that? Let me save this one. Let me run this code. See now, first Mahesh, based on the hash code, it's printed. Again software. Again search. Here, first it's printed this one. Again this one. Again this one. Based on the hash code. We know already. We saw what is meant by hash code. If you just take print out this one, print out all object of this values, then it's printed based on the hash code. So set will print on the console based on the object hash code, right? In the array list based on the index, like that only. Small difference there. Clear? That is about set. Now we'll go to the linked HashSet, TreeSet, all are the same. Just update HashSet inside of TreeSet, linked HashSet. All methods are common. Why? Because of all coming from the collection interface. Clear? This is about set interface. Now what remaining today? Array queue, priority queue. Okay. We'll go to the next topic. Set done. Set interface done. Oh, This is the hierarchy. So this is the hierarchy. Collection is the interface, direct interface. So set and has set, linked has set directly implementing the collection. So all methods will come to the set because of based on the inheritance concept. After that, set interface is implementing the sort list, sort set and navigable set. These are all the some methods. These are all the some classes. So these are all the some description about HashSet. HashSet is the most commonly implemented set. It is used the hash table strong, provide the consistent performance, the basic operators like add, remove method, consists. These are all the methods we are using the HashSet, right? So that only I already explained here. Okay, the previous. Okay, these are all the methods, HashSet. That only the point here. And these are also same point, same methods coming from the collection. That is about this one. Small description. Okay, we'll see next topic, collection. Sorry, the collection framework, queue interface. Okay, it is used the elements prior to processing the following the first in first out, nothing but FIFO. Just a minute. Okay, see now, queue, it is used to elements priority based processing. Priority, okay, it is actually not printed. It's a priority based processing following the first in first out principle. In Java collection, this is the part of the Java collection. Okay, what does this mean? FIFO. What does mean by FIFO means? First in, first out. What is the best example for FIFO means? We have, let me take, no, this is not good. Let me take this one and let me take one more circle. Alright, now let me connect the points. Okay, it's a big, okay, it's okay. Now see, FIFO, first in, first out. What does mean by first in, first out means? Let me take queue. We are. This is a following queue, right? Suppose I have. Let me take different element, different color. This is one element. This is one element. This is one element. Alright. This is one element. Now we have 4 elements, right? Green one is 1, 2, 3 and 4 elements. So suppose assume it is a one pipeline. In the pipeline, the elements will passing through this pipe. Passing through the pipe. Then what will come first? Green element, right? It will pass inside and it will come out of the pipe. First it will come green element only. Clear? Right? Green element. First green element only will comes. After this color, this sky blue element will come. Again this purple. Okay. See now, assume it is a one pipeline. In the pipeline, elements are passing through inside the pipe. Then first what will come out? Whatever the first in, that only first out. That is the principle. First in is the green element. First in, that is nothing but green element. First out, nothing but green element only. Again, secondly, it will go to this sky blue element, again come out, first out this element, again this purple one, again this purple one. Based on the principle only, queue will work. And one more example, like if you are line up for the boarding the Airbus, then who will come the first? He will only check this what is called some process like check upping bag, all these things. He will only come first. Second person, he will wait on the queue and he will come from the process. Same thing here also. If you close this one, let me close this one. If you close this one exit, then the elements will go. But what we have to pick up in? We are picking the first fourth element. Right? Why? Because of the green element will settle here. The blue element will settle here. The purple element will settle here, and one more purple will settle here. Then what is the first element we are picking? Fourth element. Nothing but this one. Right? This is called LIFO. Last in, first out. What is entered the last? Fourth element. Fourth element is entered inside. What is the first out? Fourth one only. Clear? If it is closed. If it is not closed, this element will come first. That is nothing but FIFO. If you close this one, entrance, it is LIFO. Last in. What is the last in here element? This fourth element. And first out. This only will come first out. That is called LIFO, and that is one FIFO. But we are using here FIFO in the queue. In the queue, it will hold the element based on the priority to processing. Follow the FIFO principle. Already we know what is meant by FIFO. It is a part of collection framework already. Okay. So see now, collection is one framework. Queue is the child interface of collection. DQ is the child interface of collection. So these classes, linked list, priority queue, array DQ, these classes are implementing these interfaces. Clear? So what is the syntax for queue means? It is the interface, right? Queue. Queue is the interface. This is also recommended based on the polymorphism concept. type, nothing but we have to give here type, nothing but integer, string. These are all the data types we have to add here, and these are all this is the object name and a new keyword and a linked list. This is the syntax for the queue, and it is the okay, this is the recommended. Let me remove this one. Okay, this is the just syntax based on the priority, this one. Okay, okay, I will explain at the time of this one. Okay, so that's tomorrow. Okay, key points. Let me go to the code part. How to achieve the queue? Just right click on it, go to the new, go to the class. Let me create a queue, right? Queue sample. Let me check it. Public static void method id will generate the structure. Then what we have to do, we have to create object for the queue. What is the interface here? Queue. After that we have to give here class name. Let me remove this one. Let me write linked list class. Okay, linked list. Let me give here queue interface. Okay, first let me import this one. Now let me update this one interface and queue. Let me put all the classes, save this code. Let me update the variable with something queue. Okay, recommendations. Okay, see now I created one class in the com.bt.stream collection package. I imported the java.util all classes with star mark, and in the main method I created object for the linked class. After that with the new keyword, this is my variable, reference variable, and this is my queue is the interface, right? Queue is the interface. So in the interface all methods we are implementing with the linked list class. I choose the linked list class. So whatever the methods available, abstract methods available in the interface, we are implementing we are using in our application. That is the process. That is the meaning of that 8th line. So what are the methods involved in that queue? Means same queue object dot non-static method add. Okay, let me give some alphabets. Save this one. Q dot. Let me add some alphabets right now. B. Close this line. Okay, let's add all. So, let me add one more alphabet, C, just for coding purpose. Let me print the elements which added in the queue. Let me see now ABC added. After that, now let me add one more method. We have lot of methods, right? Innumerable methods. Q dot, let me add one method, some pool. And it is returning some integer value. Let me put that one variable, that data type is okay. Just see this one. What we have to remove? Just let me write. Let me add this variable. Just save this one. Let me run this code. DA. See now, up to now we know this is added elements. After that, pool. Pool with the reference variable dot pool, it is returning one element. Whatever the element stored in that, I printed. It returned some DA. Right? What is in my DA means we will go. Save this one. Let me run this code. A. Okay. It's removed A actually. System.out.println. Let me write after remove a element. Let me print this object. Let me save this one. Let me run this code. Okay, BC available after remove the A with this method. So with the pool method, I removed the A. After that, what I removed, after that you will print the Q. What does that mean? Means in the queue, we have head and tail. Right? Head and tail. In the head, one object available. In the tail, one element available. So what is the, if you come to this one, head point. See now, I will explain these key points. Now I am going to explain this code, right? Since I am explaining this code. PriorityQueue based on the priority. We don't have any data structure for this. Okay, this is one point. So this is the internal default size of queue. We have to, if you create one queue, the default size is 11. If you go to the set, default size is 16. But it stores the elements not in the sorted order, right? It's not printed on the sorted order. If you arrange A under the fourth line also, it won't print the ABC. It will print the some CBA like that. This is not following the sorted order. And one more important point, head point position is the high priority. Lowest integer value will print first. That is the reason it is removed the A and it is printed the BC. In the tail, in the head and tail point, this is a point. Head pointing position. Whatever the head pointing position is the highest priority. Low integer value is the first out. What does this mean? Means if you take integers, let me, here I took strings, right? Now let me take integers and add it in the generics. Let me add integers. Now let me add integer 10. Let me add integer 11, 12. Now this is all okay. Let me put in comments. Okay, it is showing error because of I have to change to integer java.lang package. Now see. So I added 10, 11, 12. It is not following the insertion order, right? Let me run this code. 10, 11, 12. Now what is the 10, 11, 12? Suppose if I add 10 under this, save this one, it will follow the principle. 10, 11, 12, again 10. It will follow the FIFO. Why? This is the first out, first in, again first out also 10 only. This is clear. Now we have the same methods in the this one. Queue, add method, right? Add method, poll method. These are all the methods involved in the this one queue, same as the collection. Why? Because of queue also implementing the collection. That's why all methods, whatever the methods available in the collection, all will come to queue by the inheritance concept, by using inheritance concept. And this is the thing, by follow this principle, this is the following the principle of queue. This is one thing. And let me iterate this all code for that for each loop. Iterate, no, not this one. Let me write for each loop, in the for each loop. So already it took the my reference variable and one temporary variable. Let me print and output integer. Let me copy and let me paste over here. Let me run this code. Let me write one segregation right. Save this one and let me run. It will iterate and it will print the numbers. Whenever the element not available, it will come out of the block. This is about queue. Clear? So it will follow the FIFO principle, first in, first out, and we are using the one for each loop. And what is the default value? 11. Clear? This is about simple concept queue. And DQ also same, right? DQ also this implemented classes, right? This array queue, point priority queue, these are also same. In the place of, if you add a linked list, if you add the DQ, same methods we are using in the classes. Clear? That is about DQ. Next class we will discuss about servlets. Just a minute. Next class we will download about we will learn about servlets. We will download Tomcat server and we have to download Java WE. Right? How to achieve this servlets code we will see next class. Okay, that's it about